So TRI, TRI implants is not new to dentistry or let alone digital implant dentistry. Our founder, Tobias Richer, who is shown here on your screen, he actually started at Straumann back in early 2000s as one of the developers and engineers and product managers of SLA Active. Our chief technology officer, our CTO, his name is Sandro, also helped develop the bone level implant. Okay, and then Holger, who is Holger Cass, who's actually one of our other engineers and head of training and education globally, is another former Straumann engineer that helped develop the bone level tapered implant and surfacing as well. So we kind of have a rich heritage through that Straumann organization, if you will, and that's a lot of that quality that comes to TRI and even more. Tobias also launched the European division of Implant Direct in 2006, and then since sold that when Implant Direct, for those of you who remember, Implant Direct was sold to a company called Danaher, now Invista. Tobias sold his company, the European division, with Jerry Niznik of Implant Direct, and then he started TRI, which is considered to be Tobias Richer Implants, or through research and innovation, we like to call it. So we've been in business since 2012. The Matrix implant, which we'll talk about today, is about 5 years old roughly, and 100% thinks digitally. Everything we do today around digital workflow, from placing the implant, restoring the implant, and seating your prosthetics, is all done through a digital workflow from design, manufacturing, etc. Everything is milled and manufactured in Switzerland. We're a Swiss quality company. As you know, some of the big implant companies in the world are Swiss based. So everything we do is research and development, milled, manufactured, and packaged in Zurich, Switzerland. And most importantly, I think that this is one of the best ones we have, is simplicity. When you look at your implant cabinet today or your implant shelves, you're having to order multiple implant sizes, multiple abutment sizes, multi-units have different angles, different heights, multiple healing abutments, multiple impression copings. This becomes very convoluted for the staff. Yes, they're probably trained on that system at this point, but why not think differently and become more simplistic? And our company today, we only provide implant and screws because this is an abutment-free system. And I'll get into that a little bit today, right now. So when you look at overall multi-unit abutments in your practice, I want you to think about today is, some of those challenges that you've been faced with multi-units. And why did multi-units even come around? Well, in the early 2000s, multi-unit abutments were really invented for the all-on-4 / all-on-X technique to correct angulation, right? We wanted to correct the angulation of the implant so you could tilt implants and get the larger AP spread on those prosthetics. It also helps with the mechanical load, right? So you're seating the prosthesis onto that. And then most importantly, it raises that implant platform to that tissue level, so you're working at tissue level. Some of these implants are not designed to actually have a prosthetic seat into the implant. But there's a lot of complications. All of you that have done multiple cases over the years probably have experienced a lot of these complications as well. For instance, tie-based debonding, big one. I've been in this industry a long time, and I can tell you right now that my phone has been texted repeatedly about tie bases debonding from the dental lab. Excess cement problems causing implant failures. Incorrect selection of your multi-unit abutments. When you look at the multi-unit abutments that you do have in place, how many times have you gone back for final restorations and having to change out a multi-unit abutment for a different angle or a different height to make it more ideal so that your prosthetic seats correctly or you have a correct access channel? A lot of these FP3 cases, when you do an FP3 style case, you're having to reduce more bone in planning phases. It's just second nature now. You're having to take more bone off because that's what you're used to and you're trained on to create that height space and that interocclusal clearance for your prosthetics. With TRI, we've eliminated a lot of those problems, and I'll show you that here shortly. And one of the other biggest things that we are able to overcome now is screw loosening and screw breaking. I would say over the last 5 to 6 years, I've seen more prosthetic screws come to the market. And if you're part of these Facebook groups, Instagram, everybody's got a new screw out of some country that they think's the best little screw out there that they can torque to this certain amount and it won't come loose. Let me tell you, and I know you guys, some of you are shaking your head, yes, they all come loose. They all break. If they're not seated correctly or milled manufactured correctly or printed with those printed provisional correctly, they will come loose. They will break. When you look at those micro screws that you've been using today on those prosthetic screws, that's the only solution that's been around. until now, until TRI launched the bolt screw. And when you look at these added complications, you're at total, I've looked at some of these dental offices that have these large like inventory cabinets of Neodent and Nobel that have, 2/3 of that shelf space just taken up on multi-unit abutments. What if we can eliminate that for you? So I want you to think about that as well. And then added cost, right? When you look at your overall case cost, what does it cost you for 4 implants, 4 multi-unit abutments, 4 extra components for temporary cylinders and other stuff, and then your final prosthetic? Some of the other challenges with multi-unit abutments we talked about, I threw out there, was obviously gleam through, creating problems because there wasn't enough bone reduction or tissue loss, and the abutment shines through. Well, we're here to change that for you, and we want you to think a little differently, because TRI implants that you see here, the TRI implant is designed for an abutment-free solution. It's the only FDA implant in the US without an abutment. Okay, every other implant on the market today requires an abutment or some type of attachment to go onto that implant. Okay, whether it be a tie base or some type of cylinder. Our power base, which you're seeing on screen right now, which is, we call that pink collar, the power base. That power base is actually integrated into the implant, and it is a multi-level implant. I want to stress this right now. This is a multi-level implant. So it can be placed in the bone, at bone level, slightly above bone level, supracrestal, or if you got a nice FP1 case that you're working on, and you need to leave that collar a little proud or supracrestal because it's a beautiful FP1 style case, you can leave that collar high, a little high. That collar is only 1.8 millimeters. I want to stress that. It's 1.8 millimeters tall, not very tall at all. Multi-unit abutments start at 1.5 millimeters. So the beauty of that collar being anodized in surface is that if you do place it at bone level or slightly above bone level, you will notice that the bone will integrate and grow into that concave shape, and will not have bone loss going down to that first thread at all. And we have some cases to show you on that as well. And then combined with our 2.8 millimeter bolt screw that is on the screen here, you will be able to eliminate a lot of that screw loosening. And I can confidently tell you today that we've only had one case with over 20,000 units that I've heard come loose. And that's going back to the doctor actually didn't torque it down to 35 Newton centimeters. He torqued it down to 30, and one screw did come loose. We do not have screw loosening problems. We do not have screw breakage problems. This will actually help your practice and your patient experience overall. I wanted to throw this out there because this is a great comparison on how you want to hold your final prosthetics on the teeth. Do you want to hold your, when you're looking at the future of your patients, are you feeling comfortable holding these prosthetics on with a tiny prosthetic screw? Or would you rather have something that's more robust, a little bit thicker, with more peace of mind at a 2.8 millimeter bolt screw? And just in comparison as well, this is a great comparison with the actual driver in place. You can tell that the one on the left is your typical prosthetic screw for a multi-unit abutment, or our 2.8 millimeter. This is actually a 2.6 millimeter bolt screw, and I'll tell you the difference on the two screws. We have a 2.6, which is for angulated screw channel. So you can angle the screw. We can design it so there's angulated screw channel through the prosthetics, and we have a 2.8 millimeter for a straight. With this imagery here and this animation is actually just showing you the connection. This is how our prosthetics seat into the power base and smart lock. You may take note here that the pink collar does not exist on this implant. That is because this is a bone level matrix implant. We do sell bone level matrix implant, but we only really recommend that if it's for a thin mucosa type, less than 1 millimeter tissue, maybe it's a knife edge type ridge that you really just need to maximize the space best as possible. We have this as more of an emergency implant or a treatment planned implant that the tissue is going to be really thin. So we do have a bone level available as well. But this here is our workhorse. This is our TRI Matrix multi-level implant. This has the pink power base. And you'll notice here that the little locking mechanism, that's called a smart lock. That's that notch inside the implant. That notch is only for anti-rotation on the crown. That's it. So when you see a single tooth crown, that notch is in place, so it helps the anti-rotation and it locks in precision within a 10 micron fit. One thing to highlight here with the bolt screw, we do not have micro movement. The bolt screw absorbs most of the energy on the chewing forces, and I'll show you a little animation here momentarily on our strength, a little video on our strength of our implant. But when you combine this power base with that bolt screw, it absorbs most of that energy as a patient's chewing on their crown, and it reverberates vertically. Okay, what is the difference of a standard implant system? Well, a lot of these implant systems, let me see if I can annotate here. Should have had this up already. A lot of these implant systems, it's not going to let me do it. Maybe it will. Apologize, it's not letting me annotate. A lot of these implant systems here, they thin out the wall in the connection. So if you can imagine, the abutment goes down deeper, which then reduces sidewall thickness of the implant, which also transfers energy laterally. So if you guys have ever had an implant split or fracture, that's because there's not enough material on the sidewall of that implant, and a lot of that energy is being taken into that implant. Instead of ours is very robust, it's really thick on the sidewall of the implant because the abutment's not going down in there deep trying to take up room for the implant strength itself. Same thing with the zirconia. Some of you may be thinking about, well, I've had zirconia break. With our system, the way it's designed in the bolt screw, you actually have more material of thickness of zirconia, which comes, the thicker it is, the stronger it is. You have more material there so that the bolt screw can lock in between the bolt screw and the implant itself is 2.2 to 2.5 millimeters. Typical implant systems is around roughly 1.8 to 1.7 millimeters thickness. That's why a lot of the implant systems can't do zirconia directly to their implant because they fracture. With our system, you're doubling the thickness of zirconia around it, and that strength the thickness comes in strength, so it won't break. Moving on. I like to also teach you guys a little bit about our state-of-the-art digital app process. Okay, so we like to call this our 10 integrated apps within the store. This app is just like the apps on your cell phone. You want to work through these applications in your practice very seamlessly and simplistic. I'm going to talk to you a little bit about Scan and Smile, which is the first app here on Scan and Smile. And I'm going to talk to you a little bit about the DHC, which is Digital Healing Collars. I'll also mention a little bit about ScanBridge, which is like a photogrammetry or kind of like an OptiSplint version that's free. We'll touch on a couple other ones here. I won't go through all of them just for the sake of time now, but I encourage you, if you want to learn more about these applications and how they benefit your practice for little to no cost at all, this could really be a big benefit, including, which is not on this presentation today, but is launching this weekend. We're launching an AI-driven crown software for design for single tooth up to 3-unit bridge that you can upload a immediate implant. You put in immediate, you scan it, you upload it to our software, and within 5 minutes or less, you'll have a design proposal back that you can modify or send directly to your printer and have a crown printed. So that AI software is launching this weekend at the EAO in Monaco. There's a big EAO conference going on in Monaco right now, and that software is launching as well. So talk about a little bit about Scan and Smile. Scan and Smile in 1 hour currently is actually going to get down to about Scan and Smile in a half hour. Okay, so just in this particular instance, with the AI software that's launching, you could place an implant, scan it, have a design proposal, and print it, and probably seat this crown in 30 minutes. Okay, right now it's about an hour. So this particular case, this is our good friend Dr. Ryan Dunlop. This is actually on his father-in-law. Dr. Ryan Dunlop's father-in-law came in, had a broken tooth off. It's an old endo. He extracted the implant. He put in a TRA matrix implant, as you can see here. He went out and prepped the osteotomy. He used a 3.75, it looks like by 13 roughly implant, and he inserted that implant for immediate tooth. Once the implant's torqued in, he goes ahead and puts on a scan body, which is in the bottom left. You'll see that the scan body is a gold color. He puts the scan body on. He then scans it with his iTero. And then the little top center photo is just a tissue healing collar that he put in place just while the design was being done in the print. So now the patient just rests for about 20 minutes. The crown goes over to design, and he 3D prints this crown in about 8 minutes. For those of you that have a Sprint Ray Midas printer, the Sprint Ray Midas is printing in roughly 7 to 8 minutes on single crowns now. It's incredible and very, very good quality. So he prints this in about 7 to 8 minutes and then screws in the tooth. Patient goes home happy as can be. The beauty of this is I wanted to show you, if you guys are looking at this x-ray, you'll notice the bone levels. Okay, so he placed this implant roughly at bone level. And I'll show you the final x-ray here when he sees the final crown. This is a 2-appointment visit. Okay, the patient showed up with a broken tooth. He placed a TRA matrix implant. He scanned it. He put on the temporary. And then he actually scanned the temporary for the anatomical shape of the sulcus of the temporary just before he seated it, so that his lab tech, his designer, can do the final crown. And so a short 3 months later, his father-in-law comes back because he lives out of town. He lives in Southern California. Dr. Dunlop's in Fresno. His father-in-law comes back. He takes the temporary off, and look how beautiful this tissue is. And that's because we use the Onyx Tough 2 resin, which actually gets really good epithelium attachment in that temporary. So the tissue's perfect, the implant's perfect, the crown is already milled and polished and fired. It's ready to go to seat. This is the patient's second appointment. He then goes ahead and takes the temporary off and seats this beautiful crown. And as you can see here, 3 months later, the bone levels have actually improved into that collar of the implant on the left side. And then this is a good comparison that his father-in-law actually has a neodent implant in the other tooth right next to it. And I would argue that the bone levels actually look a little superior to the TRA matrix implant. So he's got a matrix in one central and a neodent on the other. So we'll see, maybe do a follow-up study in 5 years to see how everything looks. But overall, this patient got blessed with a 2-appointment visit and a beautiful final crown. And Dr. Dunlop did a great job. So overall, enhancing your patient experience. At the end of the day, everybody can show up and talk about chair time, and everybody can come to you and say, hey, I have the next best widget on how to save you and your patient an appointment. But what we're doing is we're providing a better solution and workflow that actually gives your patients a better experience. And more importantly, hopefully they go tell other patients and other friends and family on how good of a dentist you were by placing this type of implant in this type of workflow, and not having them back for 5 or 6 different appointments for impressions and seatings and everything else. So moving on here to digital healing collars. This is part of my two more things to talk about, and I'll turn it over to Dr. Bigler. Our digital healing collars are amazing. These are printed in Onyx Tough 2 resin. These are game changers. So some of you that are using anatomical shaped healing collars out there today, awesome. This is printed in Onyx Tough 2 resin instead of PEEK. The PEEK healing abutments that are on the market today, or some of them are even acrylic. The acrylic ones are really bad. I highly recommend not using those. The PEEK ones are good, but they cost a lot of money. Well, these are free. Let me back up here so you can see the animation. These are free, and you can actually, when you become a TRI customer, we send you these at no charge. You can use these for anteriors, premolars, molars. They come in different heights, different sizes. You got small, medium, large, and all it takes is one of our bolt screws to hold it on. You just pop them off the little tray here. You pop them off, take a little rubber wheel, and then you polish off the little nub. Seat these inside. I'm going to show you a couple examples here. You know, these things are very valuable, and a lot of companies probably would charge for these. We decided not to, because it's for the benefit of the patient and the patient experience, and most importantly, your final crown outcomes. So we give those to you at no charge. More importantly, if you wanted to get the STL file, we'll give you the STL file. You can print as many as you want in your own office too. So if you're a busy practice and we don't you don't want to pay for the shipping or something because you just need some digital healing collars, we'll give you the STL file. You can print them on your own. No big deal at all. Our good friend, Dr. Siobhan Patel, is in Chicago. For some of you that may know him, he did this case here. Patient came in and had a TRA matrix implant placed in the first molar. He used a digital healing collar. It was all healed up, ready to go to final. The tissue looks amazing. Now he's got a beautiful sulcus created so that he can actually have a molar crown placed in this patient's mouth, where it's not a little tomato on a stick or a really tiny access hole in the tissue that you're trying to compress and push away with the crown. So now you can see the final crown goes in, and there is no black triangles. There is no food trap. These digital healing collars really help develop that tissue so that you have a perfect crown that fits in that mouth. And you can see here, just in an X-ray overlay, that implant was placed just slightly supracrestal, and rightfully so, because you could see that the molar next to it If you look at the two teeth, the crown versus the tooth itself, they're symmetrical, right? The emergence profile symmetrical. So he did a good job placing this implant, just supracrestal, and the bone levels have integrated into that collar and looking really good. Here's another one for Dr. Shivam Patel. He took out a molar. He placed a TRA matrix implant with another digital healing collar. He decided to take this one step further because the patient actually had a broad smile, so he didn't want to see the white in the back. So he used his staining glaze kit in about 1 minute and just touched it up with an A4 color and a staining glaze kit and actually toned down the white. TRI has now actually gone to print these in A1 shade. We do not print them in bleach anymore. We were excuse me, we were printing these in bleach color. Now it's A1 shade, so they actually are a little toned down. But if you ever need it, it's Onyx Tough 2. Pull out your staining glaze kit, good to go. Getting into full arch a little bit. On the full arch side of things, we have this power base I talked about with a 50-degree divergence. So when we talk about full arch workflow and why we do not need multi-unit abutments, is because our prosthetics will seat directly onto that power base, even at different angles. So if you decide to tilt the implants at 30 degrees, 17 degrees, we still can see passively the prosthetics on those implants. And I'll show you a couple of extreme versions here momentarily where some of the implants are placed at 70 degrees. And part of that animation you saw there at the very end was you looked at the screw access channels being deviated. That's because in exocad software with our bolt screw, you can change the angulation. So if you put your implants in at 25 or 30 degrees posteriorly, going backwards, we can actually move that access channel up to 30 degrees. So you have a perfect access channel going directly down the center part of the tooth. You can see here, this is Dr. Shivam Patel again. This is a full arch case that he did, TRA matrix, and we were able to change those angulations as needed so that the screw access channels were perfect. Here's this case right here that was seated with a nice little overlay. Again, so if you're used to angling implants or you need to angle those implants because of increase of AP spread, that is not a challenge with our implant. We have that all worked out. The engineering team has been doing this for 5 years, like I said. We haven't, let me show you here in 1 second. We haven't seen an angle that we can't overcome, to be honest. So full arch dentistry is the name of the game pretty much in what for a lot of you that with full arch practices, excuse me, is the name of the game. Obviously, some of you have photogrammetry. We are compatible with all photogrammetry systems in the market today. We work with PIC, Micron Mapper, iCam 4D, iMetric. And the interesting thing with photogrammetry with iMetric, we actually make the dominoes, or iMetric makes them for us. We make the dominoes that go directly to our implant. Okay, so some of you might be thinking, oh, I have the dominoes already for multi-unit abutment. How does that work? They are a new set of dominoes that go directly to our implant. You work with us, and we walk you through that individually, depending on what system you have. With Micron Mapper, they're in the works, but we also have these multi-unit adapters that work really well for the Micron Mapper system. So any of those systems that are on the market today, we have the ability to work with. I wanted to mention just a little thing on ScanBridge. ScanBridge is down here in the lower right corner. That's kind of like OptiSplint. These are these little connectors, and I'll show you a recording here momentarily. These little connectors that you link together with our scan bodies. The scan bodies you see on the screen here are gold, and they clip into the scan body. So they actually lute onto the scan body with a little bit of light cure composite. You just clip them on the scan body. You figure out what size it works. You got kind of an extra small, medium, large, extra large, depending on your span. Once they clip into the scan body, you just put a little composite, a little dot of composite, and you light cure it together so they don't swivel. And then I'll show you how that works here momentarily. But I wanted to point out these are free as well. So if you're in a situation currently in your practice where you don't own photogrammetry, we have a solution for you. These clips work really, really well. Here's a little scan just to show you on how that works. You clip them together, a little composite, and you go across the arch. The bricks. So clicking the folder. There must be a machine button. So one thing to point out there is all the little flats and triangles, the little rectangles and triangles and sharp edges. That's where the photogrammetry kind of comes in place with the intraoral scanner. The intraoral scanner itself is not as accurate going across a full arch when you don't have reference points. When you connect all the scan grids together, it's giving it more data points to reference so that your designer can align everything together. So it works really well. And these work phenomenal for in conjunction with photogrammetry too. So if your designer, if you want to improve your photogrammetry system, actually, and instead of just doing a rough kind of hamburger tissue scan, you can actually use this and put them together and just use this for your on top of your tissue scan. And your designers, we work with them and they show them how to use it, so you get more of an accurate scan on how to seat those provisionals. But that's for immediate workflow, obviously, when it comes to that. And you can use the scan bridge for finals as well. Now I mentioned the angulations. So this is the case of kind of what not to do. We don't want to highlight 70-degree angulations, 60, 70-degree angulations, but this is more to highlight of our capabilities. This particular doctor placed a TRA matrix implant at a severe angle here. But we were actually, through our milling manufacturing, we were actually to produce a final prosthesis using angulated screw channel to correct that angle and move the access channel back through the occlusal teeth so the doctor can actually torque it down. It was a little tight in the back of the mouth trying to get the torque wrench down there and seat it, but he was able to do that. So our milling capabilities are next to none when it comes to angles, okay? Because we use, $500,000 milling machines. We're not using a $30,000 desktop milling machines by all means. So we have a really good quality milling machine that can take care of cases like this as well. This particular doctor that restored this TRA matrix implant actually didn't even place the implants. He was the second opinion that came for the final. But I also wanted to highlight, not for every case, but we do make a rescue MUA, a rescue abutment MUA, and it's not for every case, and it's a 45-degree angle. So if you happen to have some type of implant like this, because sometimes these patients you got to put the implant in where the bone is. We do have an option to divert that into a multi-unit level case through our rescue abutments, but we highly don't recommend it. It just adds extra cost. It's so much easier just putting the implants in, at a reasonable angle. This is one of my last slides here. I wanted to show you. This was done with Holger Cast, one of our engineers, about 3 or 4 years ago. And this is about the strength of our implant.
Ground, which we just have freshly cut, and we have packaged tissue level matrix implant, and we have a 2.8 zirconia screw. And then we can go on 35 Newton centimeter. So then I have this cylinder, and I place the implant in the cylinder on this ground. I'm going to add as much weight as least as we tested it in our official test. So that's the first 1.25 kilos, 7.5. This is the next 2.5 kilos, 25 kilos. Right now, we have 80 kilos, the maximum of any human can bite. So how is your bet? What do you think? How much more? 100 more? 150 kilos on one single crown, 165 kilos. Okay, to finish that, I will add all the kilos on it. 177, that's enough. Woo! I think that's amazing.
Just take note here on the last image, you'll see the tooth indications in the aluminum. How strong the zirconia was with the bolt screw. And just for reference in kilos versus pounds, it's about 380 pounds of pressure in one spot, right? Obviously, a little bit difference about pounds per square inch. Oops. Sorry about that. A little difference on pounds per square inch, but any human cannot bite 380 pounds forcefully. And that's where the strength of our implant combined with the bolt screw and a zirconia crown all come together. We have lots of studies. So anybody that needs some reading materials and you question anything that you actually want to see some research on, we have plenty of that for you. We have a scientific journal with lots of studies from the University of Zurich with Dr. Ronald Jung. For those of you that may know Dr. Ronald Jung, he's the president and the head of the ITI. He's actually a good dear friend of the TRI's C-suite executives, and he does a lot of research for us. So Dr. Ronald Jung is a lot of our research. There's other doctors as well, but lots and lots of clinical research behind us. We have nothing that goes to market without clinical research behind it. The white paper that's being highlighted in front of you is showing 100% success rate on crowns. So a lot of questions come up from doctors on how strong is the zirconia and why doesn't, and it's got to break in the implants. They do not break when it's milled and manufactured correctly. And our good friend Chris May from May Dental Arts in St. Louis, Missouri, if those of you that know May Dental Arts, phenomenal lab, high quality lab. They were actually one of the first laboratories in the nation to start, actually I think they were the very first lab to start producing crowns for TRI. Over 388 single units in this white paper study were produced at 100% success rate. No screw loosening, no zirconia fractures. On bridges, 357 bridges were done. Again, 100% success rate, no fractures. And the one I love the most is the full arch zirconia restorations, 812 units. That's 340 implant sites, 464 Pontic sites, 100% success rate, direct to connection to our implant combined with our bolt screws. And he considered anything that would fracture or fail or a screw loosening would go into the study. Nothing ever came back out of the study, and we're happy to share that with you as well. So our last and final value proposition that I want to highlight to you guys is about the prosthetics and some of the cost, and then I'll turn it over to Dr. Bigler. Price compression is rampant in this market today. Insurance companies like Delta Dental and many others across the U.S. are just price compressing everywhere which way they can. Dental implant companies have dropped their price as much as as possible to help you guys afford to do more treatment for more patients. The dental labs itself are reducing their prices the best they can. Well, we've came out with something a little bit more appetizing. I think that combines is kind of our third value proposition with our implants. For a basic monolithic zirconia arch, which is like a Bruxier kind of monolithic for, kind of, it's still translucent, but for your everyday type arch, I call it our value arch, is $999. For your ultimate kind of higher aesthetic arch, which is like a multi-layer, high impact strength, higher translucency arch, which probably you're more used to, is $1,500 an arch. Okay, and that is fine. That's a finished final. That includes design. There's no hidden fees. That's shipped to you in a 2-day air package. Okay, most of you are probably paying between $2,200 and probably I've seen as high as $5,000 for this type of arch. Our price is $1,500. For those of you that have an in-house dental lab with a technician that you love and you have milling, etc., and maybe you just have some overflow that wants to come to us, we have a milled and centered option for $575. So if you want to order, you guys design it, you send it to us for manufacturing, and we will mill it, center it, and return it to you for finishing for $575. The last one here is the single crowns. Again, the basic monolithic kind of Bruxier crown, I call it the value crown, is $120. If you're looking for something a little better, multi-layer, high impact strength, high aesthetic crown, it's $160 for an implant crown. I don't know of anybody in the market today that can offer that type of service, quality, and price point and combined from our implant from a root to tooth solution. I've been in the lab business. I've been in the implant business a long time. I think the best prices I find on the market today, the best of the best of the best with a custom abutment would be like $199. But the gold standard, I use Glidewell as call it the Walmart of the nation, if you will. The Glidewell prices are about $300 for a custom abutment and crown, $350 even. And then I've seen crown prices and custom abutments all the way up to $700, right? And we're looking at the high quality crown for $160. So I wanted to plant that seed with you guys on our third value proposition on what we bring to the market for you and your offices. And then most importantly, we back everything with a guarantee. Your patients get this beautiful TRA Matrix medical device card, congratulating them on their new smiles. And it's you sign it, you give it to the patient, and this gives them their 10-year warranty on their prosthetics. So you get a 10-year warranty on the prosthetics and a lifetime warranty on the implants. So with that, I'll take a pause. Any questions come to mind, please put it in the comment box. And I look forward to turning this over to my good friend, Dr. John Bigler. Thank you for your time.
All
Dr.
right.
Bigler,
Derek, thank you. That's awesome. Appreciate all the insights, and as is very evident, Derek and his team are very well versed in the details and the sales side of it, and all those nuances. And having me on here, I think it's just because they want somebody on here who can prove anybody can do it. So I appreciate giving me that opportunity, Derek. Let's see if I can share my screen with you. If I can work the technology, we'll do that. Here.
there we go. It's coming up.
Is that everybody able to see that now? You got that, Derek?
Yep. We got it. Yep. It starts with why. Yep. What's your
There
why?
you go. So, you know, I all I can do is really tell my story and my experience. And most stories, I think all of us have to start with why. What's in it? What do I want? And so I hope by the time we're done today, you take a minute and ask why. Why are you taking time out from your life to look at this webinar, to listen to another implant dentist from who knows where across the country from where you're at? Think about why you're taking that time, and hopefully when we get done, you'll be able to answer those whys for you. To get started, I'll tell you a little bit about myself, and hopefully by the time we're done, you'll understand my why. I'm the dashing, strapling young warrior at the front of that picture there. I grew up in a saddle in northeastern Arizona. This is a picture of me and my dad young. And graduated from Arizona State University, went to the University of Colorado for dental school. And my life and my energy, it revolves about my family. And I can't ever get through these pictures without getting a little bit emotional, because that is the basis of my why. And if any of you are like me, you blink and all of a sudden your family grows, and your family. I wasn't gonna do that. Sorry, guys. Really becomes your why. And my story and my experience with TRI and implants happened about the time of my youngest son's wedding. And it's kind of interesting, the timing. This was a little over a year ago. And I had been doing implants for the past 20 years. And I was always carrying questions with me. And maybe some of you have had some of these questions, and I know Derek kind of hit a few things on there, but I was always questioning myself, is there a better way to do these hybrid surgeries without reducing so much bone? You know, you went through dental school and everything was about how do we become more minimally invasive. And then I learned to do all on four hybrid dentures and prosthesis. And one of the first things we did was reduce a ton of bone. And that always bothered me. The other thing was it was so complicated. We had all these little parts and pieces. So I was constantly, and like many of you, trying to figure out how to streamline a process, how to make it more efficient, how to make it better for the patients. You know, how do I reduce my chair time? How do I reduce expenses? Another thing that was very frustrating that I was dealing with at the time is, you know, we were converting these acrylic dentures, and we would have fracture problems, maintenance problems. You know, Derek even mentioned about having a whole, you know, shelf full of MUAs and the cost for that kind of thing. You didn't talk about the ones you drop on the floor and kick under the chair, those kind of, you know, those were all added. And at the same time, over the years, there's been plenty of implant companies come and talk to me, and I've used different implants over the time over the past 20 years. I've been a KOL for multiple implant companies, so very familiar with them. And you know, I came down to when an implant company would come to me, I would start saying, well, you know, if I could do the surgery without having to reduce bone, you know, I'd be in. I'd like that. You know, if I can eliminate a lot of my lab fees and this mess, that's what I'm looking for. If I could just use a full digital workflow and print things in my office and do it here, have more control over it, and have something strong, then I'd be really interested in that. You know, if I could make it a fully digital workflow, these are all the things that we were thinking about doing, right? If I could eliminate some of the problems like the MUAs, you know, the fracturing of the screws, abutment loosening, all of those kind of issues that we all run into, right? Cementation problems, all these things. Those are the things that were interesting me as implant companies would come and talk to me. I would say, well, okay, what does that look like? You know, what are those things? And so I had a rep at the time came to me and he says, look, I've got a solution for you. You can do it in your office. You can print in your office. And we've got a matrix out, you know, an implant without a MUA. And I was intrigued, and I did let him come in, did one surgery, and the problem with that is that the very next weekend was this wedding. It was my son's wedding, and while everybody was looking at this picture, I admittedly saw this in my mind, and I realized that the technology of printing had come together with actually some innovation from the implant field. Up to this point, every implant company had come out with a new surface, a new, you know, we've etched it different. We've made the screws square. We've made our threads triangled, but no real innovation until this had come along. And so I spent the weekend, yes, enjoying a wedding, but also thinking about how this kind of technology has come together. And so shortly after that, I did a case, and I'm going to walk you through this case because I think it shares a little bit of what I experienced, and maybe bring to light some of the things that have helped me on my journey, and maybe give some insights to you. So this is a patient that came to us, edentulous upper, and you know, every patient comes to you with their why, right? What is their why? From a treatment planning and a really patient care standpoint, I'd encourage you to find out what that is when they come in. What is it that's bringing them in? For her, she recently, her husband passed away. She was kind of back on the market a little bit. She wanted to be social. She wanted to get back out, and having teeth that were coming loose and falling out when she was talking and socializing was not what she was hoping for. So we'll go through a couple images. As you can see, she had teeth on the remaining lowers. I don't want to lose any more teeth was her big thing. I don't want to lose any more teeth than I have. We'll talk about that as we get closer to the end of her teeth. This was a scan with her prostheses in place. She had a lower partial, upper, full denture on the upper. And here's a quick shot of what she presented like. Super nice lady, but you can see not super aesthetic. She wasn't really happy about the way that her mouth was, and was frustrated about the way they stayed in her mouth. So we did some planning, kind of some estimating, and you'll see in most of my my plans and work, I'm going to put in more implants if I can. For a long time, we kind of had this big mantra of all on 4, and it was kind of like bragging rights. We could put this whole prosthesis on 4 implants. You know, I would submit to you that was created by the fact that we had to take off so much bone. In this patient's case, if I had to reduce bone all the way across, I would have had to do sinus lifts to place implants. And that was a game changer when I started doing these cases with TRI matrix implants. Is that pink collar, and Derek addressed it. We can adjust those height based on that collar. We can sink it a little, we can leave it out, and we're able to lose the height differences that we had to do for prosthetics from an MUA and supporting bars. All of that goes away with being able to go direct to implant. And so in planning now, I'm able to use her existing bone and plan out for 6 implants, give her second molars. And so day of surgery came, we're all geared up, ready to go. And we're getting ready for surgery. And I'm just going to kind of fly through just a couple of slides. We we took some slides on this, and I don't think everybody wants to sit around and watch me do surgery, but I'll hit a couple of highlights from a surgical standpoint. Edentulous on top. Another beautiful thing about the matrix implants with a collar is that you don't have to flap everything back. And that collar sits right into the gingiva. The gingiva adheres and heals right to it. And it's a beautiful seal. Think about her long-term health in being able to maintain this. Think about her healing day after. We'll talk more about that as I get through it. But just another beautiful kind of serendipity that comes out of the design of these, honestly, first real innovative implant in decades, in my opinion. To this point, like I said before, it seemed like everything was a surface change, and finally somebody thought about what's the end and what are we trying to achieve, and I attribute that to the TRI matrix implant. So moving forward, after placing the implants, we're able to place these little scan bodies. Derek was talking about that. You can see the scan bridge. He had some fancy blue ones. These were ones printed in the office. Just like everything else, you can have an STL file sent to you from TRI. Print these pieces in your office for pennies. And that kind of relates to something else that I was mentioning. But let's see, we'll do a quick little video. It takes no time at all just to loot this little scan bridge. And that's really simply so that you don't have any kind of movement if you're bumping it while you're scanning. Just kind of a quick view of how that's done. I mean, just curing light, drop a little composite resin on there. I use flowable, just do a little flow on there and keep things from moving, and then you're ready to do your scan. I guess just kind of ease of use. I want to show a quick video on doing that in the office there. So, and let's see, how am I going here? What do I do? I messed up on how to push through here. Sorry.
There you go. Yeah, you just use your arrows on your computer, or you can move to the
There
next
we
slide.
go.
Or,
Let's get through that.
there you go.
Quick scan. I won't bore you with this. This was done in the office. Derek had a video of that we showed earlier of scanning the scan bridge in the office. Somebody asked earlier in the chat if there was abutments. Derek showed the actual anatomical abutments that we have a file of. These are small cylindrical abutments. That's just to hold the tissue in place while you're printing or while you're suturing. Again, these are they come in a file. You just print them off on your printer, or you can order them from TRI and they'll send them to you. But they come in longer, shorter. Just ease of use is great. The same screws that you're using for your prosthesis, they all fit the same thing. And so you're able to just screw those on. So I put those in place while I'm suturing. This next picture is kind of interesting. So this is a prosthesis. After taking the scan and while I'm suturing, we'll send the scan to the lab. It takes them about 15 minutes to do the design and send that back. And it takes my staff another 20 minutes to print and cure. And then this is the first prosthesis that my assistant did on her own. She's pretty proud of that. She did the contouring, she did the coloring. An interesting little thing you might have noticed that one lateral is shorter than the other. This was her picture coming to me, and she was just kind of on the verge of tears. She's like, dropped it. I chipped the edge of the tooth off. What do I do? And you'll see in the final that one of the beautiful things about the Onyx Tough is that you can bond composite right to it. So it's an easy fix. And that's something else we don't talk a lot about, Derek, and there probably could be something we could do a little bit more on that. But when you place an interim and you're using a printed Onyx Tough material, you can add and take away very easily with composite, which allows you, 2 or 3 months of healing to work out your aesthetics, work out the occlusion, and actually get a prosthetic that they really like. And that's probably, that's a lecture and part of the training that we like to do. But it's a point I like to point out that this ease of use that's come through the digital processes and the materials that we have that we're able to print from allow a lot of flexibility in our design abilities. So there you go. That is the panel. day of surgery with the printed onyx tough prosthesis in place. And she's pretty happy. She's still a little numb. This is right after putting the prosthesis in. That was her smile. Try to smile, and there we have an assistant helping her smile just a little bit. You can see that we touched up that lateral that chipped and made a quick, great prosthesis. She's very happy with this. And then a month later, she comes in, and I don't know if any of you notice anything interesting about this this scan here, but if you remember, we placed 6 implants to begin with, and she had an implant fail. And the sad thing is that no matter how much we try to control, there's a patient factor involved. And she came in and she says, "Yeah, I it was feeling so good. I was eating and I stopped right there. I said, 'What were you eating?' She said, 'Well, it was a steak and it was pretty well done.' I said, 'You realize it's only been a month? You're supposed to be eating things you can smash through a fork.' And she says, 'Well, I know, but it felt good.' Well, in the process, she had cracked her prosthesis and didn't tell us about it. So she'd had a cracked prosthesis for a month and worked out 1 implant. And so everything doesn't go perfectly, right? It doesn't go perfect every time. And what do you do if things don't go perfect? Well, you take a scan, you print another prosthesis, and take a scan, and you put another implant in. And then you already have the STL file. You just scan it and put another one in and let it heal. And this is her final prosthetic. So there's a full zirconia to implant. If you notice, look at the bone that she has. One thing that always bothered me, and I don't know if it bothers any of you, but once I take off 3, 4, 5, 6 millimeters of bone for a surgery, we know we don't get to put that back. If something goes wrong here, like we lost an implant, I have plenty of spaces around. I still have bone. And I think that's one of the things that we don't think about as these patients go through and their wear and tear on things for the next 10, 15, 20 years of their life. Are things going to happen? Yeah, things are going to happen. The more bone we can preserve up front, the more options we have for them going down the road. So I think this is a good example of that. She's super happy. There's a final prosthesis with her smile there, and again, she's pretty happy. So we took her from that to this, and the best part is her comments afterwards was, "Don't worry, I'm saving up. The bottoms are next." And that's been my experience with most of these patients, and I'm able to tell them with confidence. I've never had anybody who has gone through this type of treatment and afterwards says, "I wish I didn't." Right? They all look at themselves and say, "Man, I should have invested in myself before." Anyway, this is one of the first cases that I did with the TRI matrix. I think it turned out really well. And this is an example of a full arch case. And I just wanted to point out a few of those things. Another part of my story going forward is, Derek, you mentioned one of the other doctors and having his father-in-law. I have an experience I wanted to share. And when it comes to immediate and taking care of patients, right? When patients have a problem, how fast do they want it fixed? Especially if it's in the aesthetic zone. What's it worth? What do they want? What is that going to be? Can we do it the same day? Can we do it in the same appointment? And I think we've all thought of that. And I want to share with you a little experience here. This patient, we'll call patient GS, had came in and presented. We had done crowns on 9 and 10 here, and while in the temporary phase, she showed up for her final seats with the picture on the right of your screen there, fracturing number 10 off of the gum line. and her comment was, "What can I do now?" She was actually, the interesting part of this story is that 4 days later, we had timed it to the wire to get her crowns on, and she was leaving to serve as a missionary in a service mission up in the mountains of in Heber, Utah, at a youth camp. And 3 days from here, she was going to address her congregation in kind of a farewell talk, a speech before leaving, and wasn't expected to come back for another 9 months. So she was leaving the state in 3 days and was going to address her congregation, and really, really wanted something to smile with, and kind of came in just desperation. What am I going to do now? Fortunately, we had an answer, right? CT scan, quick planning, take out the root, place an implant, scan, provisional. And she was able to leave that day and go address her congregation and get ready to go do a mission. And we all think, well, this is great, happily ever after, great success story, Dr. Bigler. Wait, thanks for sharing. This is what I got a few months later. Quick text message. How are you? Guess what I did today? Can we FaceTime? If any of you have ever gotten that message, you know that doesn't go well, right? Oh, great. You know, my comment back, I just finished patients. Call when you're available. She proceeded to show me a FaceTime video, and I wish I had a recording of it, because she said, great, now I fit in with the rest of the country pumpkins. She had fractured her temporary restoration that we had printed that day. Implant was great, but she had fractured it off, and she said, now I look like Billy Bob. I said, well, let's, she's like, I don't know what I'm going to do. And her next comment was, I just won't eat in public. So she had figured out a way that she could kind of get the piece back on there and hold it still enough to smile. But if she used it or touched it, it'd fall back out of her mouth. And then she admitted, well, note to self, take it out before eating corn on the cob. And I had to give her a hard time, right? I said, well, that doesn't fit into the category of things you can smash with a fork. That's my comment to my patients is, look, you can eat whatever you can smash with a fork. And again, we can't always control the patient part of this, right? The patient side. But there are some things we can control. And the wonderful thing about that is that the TRI family is growing. And I made a quick phone call, and Derek, you might remember this. I sent you a text and I said, do you know any great TRI doctors in Utah?
Yep.
And he sent me a name, and I haven't got permission, so I won't throw names around. But he sent me a name, and the best part about it is I was able to get an STL file to him. He printed a prosthesis, and this is the next picture I got. I don't know about you, but the reason I got into dentistry was to help change people's lives and to make an impact. And the digital workflow that comes through these innovations coming from TRI implants are how we can change lives. To be able to call a fellow across the country, email them an STL file, and have a crown ready to put on this person, what do you think that did for her? I'll tell you what it did. I don't know how many people she emails, but I got an email that she had sent out to a group that talked about how these guys got her a tooth when she needed one. So going through cases, I'm going to go through one more case just to share with you, and then we can just chat about it. This is another case that really touched my heart. We'll call him AD. This guy is a local hero. He's one of our vets. He's served the community for a long time. He's actually a mechanic in our community. And last year, we did a little promotion. I asked my office what they wanted to do, and they said, let's give somebody teeth for Christmas. And so we we sent out some flyers, and we got some people that recommended people, and AD was one of those people that were recommended. And as you can tell, he was a pretty happy person. He's a nice guy, super great disposition, but really is pretty sad. In the previous picture, he said, "That's the biggest I ever smile." He's like, "I really don't smile." And I said, "You got such a good personality. Why don't you smile?" And he's just like, I can't stand my teeth. Can't stand my smile. So we're going to go through his case a little bit. And that's how he presented, right? Missing everything in the posterior, chipped and worn. We got some cervical decay. Just, having a rough time. He'd tried partials, couldn't stand them in his mouth. And so he was just trying to function along like this. So we did some planning. Again, I like to put in 6, 7. Looks like we're planning 7 implants here. I think we ended up doing 6. And I like this picture because I want to show you why it looks so funny. And some of you might kind of question, it looks like there's just screws sticking out of here. Well, in our learning curve, we didn't print all of our suture abutments with Onyx Tough. We accidentally printed some with resin. So the resin doesn't show up in the radiograph. And then you kind of say, well, what's going on with this one? Well, that one was edentulous, if you remember. There was no tooth there. And so, like our previous patient, that one was right at gingival level. The collar was just shy of gingiva. And we were able to just leave it open. I need to suture around it. So we didn't have one on there. So I think it's kind of interesting. The other thing that I want to point out is I didn't have to reduce bone, right? I'm able to put that collar where it needs to be without reducing bone. Now, is this the prettiest? Is this one I'd picture if I wanted to show you something to post on the wall? No, but I'm just trying to be real. This is real life. You put the implants where the bone is, and these angles, the beautiful thing about that is I didn't have to go to a drawer and find all sorts of MUAs to correct angulation. Right, we're able to scan, and with the innovation and be able to put these restorations directly to the implant, we can take care of angulation right there. So that's his smile day of. This is him waking up from anesthesia, and I'm just going to share a quick, one more little click here because I want you to see this. And watch this quick clip for us, if it'll work here. So this is him awake. He's awake now, and we finished printing the prosthesis. I'm showing it to him. And so we take out the healing abutments, place them in. If you notice, one of the things I like for my immediate temps is I just like to use straight screws. So you can see that I've got a couple of them coming out through the buckle. That's corrected in the final prosthesis through angled channel screws that Derek talked about. But this is, in my opinion, why we do this kind of thing, right? We're able to change people's lives. I wish I could share with you all the experience I had of his daughter walking in and hugging me and just hanging on and crying. So why do we do this? The why is because we want to improve the lives of other people, right? We want to improve the lives of individuals. And I think that if I have to sum it up, the reason why Derek had me come do this is that if I can do it, anybody can. Right? You can do these surgeries. You can do hybrid surgeries without having to reduce a bunch of bone. We can preserve that bone. We can actually be minimally invasive from a surgical standpoint. I could spend another 30, 40 minutes talking about the lab fees and the reduction in cost that being able to do this digitally and use printing resources within my own office has saved on a financial side. Being able to create and use a digital workflow to be able to print a prosthesis right in your office, it's way better than any of those conversion things that we were doing for years, right? You can implement these kind of digital workflows in your office. You can eliminate some of these problems with MUAs and abutments loosening, the cement problems. All of those things are at your fingertips at this point. And so I kind of want to finish by this. It's like, you know, the question really remains is, are you in? You know, are you gonna take a chance on something new? No, it's not a new surface. No, it's not a new MUA. It's not a different colored screw with a little gold paint on the outside. No, this is innovative, and it's changing the way we're able to do dentistry from a digital standpoint. Being able to share these prostheses, these changes, be able to hedge our bets for the future, we preserve bone for patients. To me, in my practice, it was a game changer. And I've mentioned before, I think Derek's heard me say this, that honestly, I feel like it is the biggest innovation in implant dentistry in a couple decades. And really the epitome of where we should be going in implant dentistry, and that is a digital workflow that's centered around patient care and what works for the patients. So that's my story. I've done dozens and dozens of arches since then. And I guess a couple of things, I'll open it up for any questions. I guess before any of those questions, as you can tell, the most important thing to me is my family. And this is our little guy. And this is him trying to tell his mom that I didn't give him cake.
That's
And,
so cute.
so anyway, I appreciate the time, Derek. If there's questions, I'm happy to answer those.
Yeah, they won't be able to talk. We do have some questions that I'll if you don't mind me asking you. I've answered some of them in the chat.
Shoot, and we can answer them together.
Yeah.
That'd be great.
Yeah, question came in from Dr. Cueva, Dr. Marco Cueva. I've gotten to know over the last 5-6 months. Great guy in North Texas there. He asked about bone reduction. His first question was, what about occlusal space needed per arch for the hybrid if we don't need MUAs? And he followed up with just that you had highlighted that you don't need so much bone reduction. Can you maybe highlight, not necessarily that you don't have to reduce bone, but maybe in what indications you don't need to reduce bone because of TRI? You know, there's still obviously a minimal thickness on prosthetics.
No, that's a good question. And it's easy to make a generalization. And I kind of did that in my comment. And you're right. I appreciate the question because it's a very pointed question. We have to consider restorative space, right? And I guess I would encourage you to think of it this way. If they had teeth at one point, they had the space at one point. Because if you think about it, the TRI matrix implant allows us to do direct FP1 restorations. So we're, again, thinking about implanting based on crown and bridge principles, not necessarily having to add that extra restorative space. So yes, you have to restore space. We have collapsed bites. Those kind of things have to be taken into consideration. But we're not having to take away extra bone just because of the prosthetics. I hope that answered the question there.
Yeah, so I think that last case kind of highlighted it for me a little bit, where you didn't really do with patient AD. You didn't really do bone reduction to even flatten things off, just because I think naturally, I've been doing this like a long time with you guys. Naturally, you case plan, tooth extraction, bony ridge, knife edge ridge thing. You're just going to flatten it off. You're like, I'll take it away. That way I'll level it off. Right. And I think where TRI comes in is you can take a different approach to preserve as much bone as possible, still considering that prosthetic space, though. I think we've fallen
into absolutely, and that's a good way to put it, because I think it's a paradigm shift mentally, especially for those of us who were placing before, and it really was almost a workflow. Extract the teeth, take the bone down, level everything off. Yeah. I think it's a paradigm shift mentally that we can say, wait a minute, do I really need to take that? Do I need the space? If I need the space, you've got to create the space, but do I need the space?
I mean, I've been in surgeries where I've seen doctors use like a Sawzall and take off 5 to 10 millimeters of bone, just flat planing things because they can. I think TRI
gives you a better paradigm shift.
Yeah. I think that gives you a better option, docs. When you think about your case planning, and we mentioned the word FP1 a lot because that's becoming a very buzzword over the last few years.
Yeah,
The TRA matrix implant is the perfect implant for an FP1 style case because it
absolutely.
allows you to put that implant at a multi different level within the tissue, right within the tooth socket. You get that beautiful integration, and you can actually scallop the bone pretty, where you can get teeth embedded into those sockets of the tissue. One of the biggest FP1 providers, I'll name it. His name's Dr. Randy Roberts, good friend of ours, with the 3-on-6 clinic in Utah. He is exclusively with TRI at this point because of our implant and that style. This is
Yeah.
thousands and thousands of implants per year practice that has migrated to TRI because of the system, the workflow, and because of FP1. So
Yeah.
I hope that
Thanks, Derek.
answered
That
your
was a
guys.
good clarification because that's exactly what I'm referring to there, is those
Yep.
principles. Thank you. And that was a great
Next
question.
question is Dr. Duhat. He said, "Thank you for the great webinar, Doc. How promising is photogrammetry, especially with iCam with TRI system? Do you have any experience with iCam personally? I don't know if you do, but I
I
know you
haven't
do."
used ICAM personally. I've seen it. I've been in surgeries. You can probably address that better than I can, though, Derek,
Yeah.
as far as ICAM.
Yeah, I think I answered it. I answered it behind the scenes, but just for everybody's understanding, those of you that have iCam or iMetric iCam, iMetric actually went back to the drawing board with us. They redesigned dominoes, we call them dominoes, that seat directly into our implant matrix, right into the matrix implant power base. So where you saw that notch, the dominoes fit directly into that. They lock in place, you screw them down, and they hang directly out of the implant interface. At that point, I'd reverse the question is, how accurate is iCam in your experience? Extremely accurate, right? It's sub 10 micron accuracy on those scans. So once you put those dominoes in place and you lock them in, now every single piece of research and study you have on the market about how accurate iCam scans are is exactly the same technique and strategies and design work. You'll have the same fit, the same passivity. There will be no difference at all. iCam is probably one of the best systems we work with. Next to that would be Tupel, and then Micron Mapper, very similar workflow. So thank you.
Yeah, that's a great question, and I think you're, Derek. I think that's what it applies to, is that you can use any of those photogrammetry methods, right, or products
Yeah.
with the TRI matrix, and you get the same results. It's the same as any other implant system.
We got one more question in the chat. If anybody else has any questions, we got about 10 more minutes left in the webinar, but we'll end early if need be. But if you have any questions, please throw them in the chat right now under the Q&A section. Happy to answer those questions for you. It's under the Q&A section, not necessarily the chat box. So the last question I saw here, you already answered one. So the one I'm going to here was Tamara Dixon. Do you have any training programs on implant placement for implant placement courses? And I think that's a great segue for your course, Doc, if you can explain a little bit about that.
Yeah, it is actually. We have one coming up. Actually, short notice on this one. This is coming up here next weekend, and this is actually a course designed for dentists who have experience in implants, really just learning the TRI process, the TRI matrix. Fast start course is what we call it. I teach that one along with Dr. Amir Gorgi, who is the clinical director for TRI, and it's here in Phoenix, being hosted this month, this next week, at Danny Dental Studios in Tempe. So it's close to the airport, close to great food. So I know it's late notice for a lot of you. If you can get it, grab it. The little QR code there, you can get in. And I think there's probably a couple of seats left for this one. If not, that QR code there will take you to the website. We've got some more coming up. We'll be setting up some in the spring, again, in conjunction with TRI and sponsoring these. So yeah, Derek, thanks again for help supporting these courses. And I think I just as a quick summary for it, this is a hands-on course, and it'll take you from surgical processes of TRI all the way through printing, staining, glazing a final prosthesis. So yeah, thank you.
Yeah, you bet. And we do have other courses throughout the country, so I encourage you to reach out to us at TRI. We do have the contact list, so I'm sure one of our representatives will be reaching out to everybody on this call. If you're just interested in education, that's what we're here for. We are not here to drive implants down your practice right away. By all means, we're here to support you and educate you on this workflow. So Dr. Bigler actually is doing a course up in Oregon through one of his partner programs in October. And we have, we basically have a course a month somewhere. So if you're looking to get going, Dr. Bigler, if there's even enough of you, we can even kickstart a new course in Arizona for you as well. I also wanted to highlight, Dr. Bigler said that one moment ago, Danny Dental Studio. Danny Dental Studio is actually one of our preferred laboratories as well nationwide. I've known the owners there, Sen and Danny, for almost 20 years. Great people. They've also came together with us on what I showed you on the TRI pricing sheet as far as a preferred partner lab. And their pricing is very competitive to that price sheet that I showed you there as another option. So some of you that may be looking for a new lab that's super high quality, even for your MUAs cases, whether it be Neodent, Nobel, or SIN, things like that are on the market today, I just want to highlight Danny Dental because they're a great partner of ours and they do a great job.
They are. I would actually add on to that, Derek. They're great for designing. Earlier in your presentation, you were talking about it was kind of a 30-minute or so. I'm usually getting designs if I set it up right through Danny Dental. We're usually getting our design back in about 15 minutes for a final hybrid prosthesis. So they've got it really dialed in, and they've worked out the TRI workflow. And so again, I agree with you. Give them a thumbs up for their contribution as well.
Yeah, if you guys are looking for design work, reach out to us. We'll be, like I said, we'll be reaching out to you. But if you're looking for design work, happy to help you network and plug you in with Danny Dental. They're doing designs under 30 minutes on a single arch. I work with a lot of designers. There's still quite a few designers that are taking 2 hours to design day of surgery, right? And I know time is money, especially for the patient care. If you're looking to speed up that process, we can help you out with that as well. For TRI cases specifically, we've negotiated those design fees for $250, by the way. The best price in the market today. Incredible. So any of you that are paying more than $250 for designs and you're thinking about integrating TRI, we have a negotiated price with Danny Dental and a few other labs as well, but it's $250 for those design fees as well. So any other questions before we let you guys go? It looks like one more may have popped up in the box here from Dr. Duhat. If you're doing an all-on-X switch systems and workflow would purpose, can you count on their design overnight PMMA? Oh, yeah. So I think if I understand you correctly, if you're to do an all-X case switch systems for TRI and workflow, would it be proposed? Can you count on their design and overnight PMMA? So how that works, what you're saying is, and if you want to take that, Dr. Bigler, but I think he's asking about design and then milling a PMMA for overnight delivery.
Yeah. And that does work out well. If you're able to get the Sprint Ray unit in your office, then that goes away because that turnaround design time is about 15 minutes and you can print in your office about 30 minutes. So I know some offices will print, let the patient go, and then deliver the next day. Others will let the patient wake up from anesthesia and then deliver, 30, 40 minutes later or an hour later as they're waking up. So it works great with either of those workflows. If I answer that question.
Yeah. I think so. And then specifically, I know some doctors, we mix up the terms PMMA versus printed on X, hybrid nanoceramic material printed. If you're actually referencing PMMA, doc, and for everybody listening, most laboratories will design, throw that into their mill production, have that milled overnight, and ships the next day. So typically it's back in your office the second day, usually 48 hours for PMMA. Maybe even 3 days, depending on if it's a Friday, things like that, right? So if you're truly looking for a PMMA that is milled, that can be done. It just takes an extra day or so for them to mill it, process it, and ship it to you, which is usually overnight, and then it'll be in your office next day air. So just keep that in mind as well. So I hope I answered your question there.
Derek, I think I'll just add to that's one of the advantages now from a digital standpoint with TRI is that you can have that design done in 30 minutes. And then print something that's actually as strong or stronger than a PMMA right there. And so that helps.
Well, with that, I want to thank you so much, Dr. Bigler, for joining us tonight. You're a great human, a great friend, a great dentist. You've done the wonders for TRI over the last couple of years, and you know, just a phenomenal practice. For any of you that have the pleasure to make it out to Arizona to the Bigler Institute, it's just a phenomenal location, and he does a great job down there. So thank you for taking
Appreciate
the
the time, Derek. I appreciate you letting some of us that you give everybody else hope when you let some of us on. I appreciate it.
Yeah, of course,
What
of
a
course.
privilege.
And
Yes, great.
And thank you for all the doctors and associates that joined us tonight. This is, you know, it's late on the East Coast. You're hitting almost 9 o'clock. I really appreciate everybody's time that was able to join us. We look forward to talking to you. If any questions you have, like I said, we'll be reaching out. Make sure you respond to our representatives or our managers. We're here to help. Other than that, we look forward to hopefully working with each and every one of you down the road. Appreciate everybody's time tonight. Have a great night.
Thanks again, Derek. See you guys.
Bye-bye.